Hello there, and welcome to the Dozing Explorer. I'm so very glad you found your way here, to this quiet harbour in the vastness of the night. It is time to let go of the day, to release the thoughts and worries you have been carrying, and to allow yourself to become soft and still. Find the rhythm of your own slow, gentle breath, and let it be the anchor for your awareness as we prepare to drift. Tonight, we will not be exploring the world beneath our feet, but the great silent and sleepy world above our heads. We will wander through the quiet wonders of the universe, not as astronomers with complex charts and equations, but as gentle dreamers floating on the slow currents of cosmic time. We will listen to the silent hum of orbiting planets, watch the slow-motion bloom of a dying star, and feel the immense, peaceful stillness of the spaces in between. This is not a lecture, but a lullaby of starlight. We will imagine the dust of Saturn's rings, each particle a tiny, sleeping moon. We will feel the ancient light from distant galaxies as it finally arrives to grace our eyes. We will sense the profound and patient dance of gravity that holds everything together in a silent, cosmic embrace. It is a journey designed to fill your mind with a sense of gentle, expansive wonder, to make the small worries of the day feel as distant as the stars themselves. And if these gentle journeys through the cosmos help you find your own deep, inner space of rest, you might consider subscribing. It is a quiet gesture that helps others who are adrift in the night find their way to this peaceful place as well. It's just a soft thought to hold and then to let go of completely. For now, your only task is to rest. There is nothing you need to learn, nothing to memorize. Let the words wash over you like the gentle solar wind. If your mind wanders, let it travel through its own quiet cosmos. If you fall asleep, that is a wonderful thing. Simply allow yourself to become a quiet, resting part of this vast, starlit, and sleepy universe as our journey begins. The moon is slowly, silently drifting away from the Earth. It is a quiet and almost imperceptible cosmic farewell, a process of immense and patient slowness. Each year, our beautiful, luminous companion moves about 1.5 inches further away from us, roughly the same speed at which your own fingernails grow. This gentle departure is caused by the very same tidal forces that pull upon our oceans. The Earth's rotation is actually faster than the Moon's orbit, and this difference causes our planet's gravitational bulge to pull the Moon forward, gently nudging it into a higher and wider orbit. This has been happening for billions of years. When the Moon was first formed, it was much, much closer to the Earth, appearing enormous in our sky, and a single day on our planet was perhaps only 5 hours long. The Moon's slow, graceful retreat has acted as a gentle break on our planet's spin, lengthening our days and giving our world its steady, familiar rhythm. It is like a boat that has been untied from the dock, not with a sudden jolt, but with a slow, silent, and almost unnoticeable drift into the great, quiet ocean of space. It is a slow, cosmic letting go written in the language of gravity and time. A single sunset on Mars can glow with a soft, ethereal blue, while our own sunsets are a brilliant spectacle of reds, oranges, and pinks. The evening sky on Mars offers a different, quieter kind of beauty. The Martian atmosphere is very thin, less than 1% the density of Earth's, and it is filled with fine, reddish dust particles. During the day, this dust scatters the red light, giving the sky its familiar pinkish hue. But as the sun sinks towards the horizon, the light has to pass through more of this thin atmosphere. The fine dust particles have the unique property of scattering the red light forward, away from the observer, while allowing the blue light to penetrate more directly. This means that in the area immediately surrounding the setting sun's disk, the sky takes on a soft, luminous, and unexpectedly beautiful shade of blue. It is a gentle, otherworldly spectacle, a quiet and cold fire of blue light against the red desert. a peaceful and profoundly alien end to the Martian day. Jupiter's Great Red Spot is an ancient, swirling storm larger than our entire planet. It is a vast crimson eye in the southern hemisphere of the gas giant, a storm that has been raging for at least 400 years, and perhaps for much longer. It is a high-pressure system, an anticyclone spinning with a quiet and relentless fury. Its winds at the edge can reach over 400 miles per hour. This single swirling feature is so immense that you could place the Earth and perhaps another 2 or 3 Earths inside of it. Yet from here, billions of miles away, it is just a silent, beautiful, and curious blemish on a great, striped celestial ball. It is a storm of unimaginable power and longevity, a permanent feature of a world made of gas and wind, a quiet testament to the immense scales of energy and time that operate in our solar system. It is a gentle cosmic hurricane, forever spinning in the deep and silent dark. The rings of Saturn are made of countless particles of ice, each on its own silent orbit. They are one of the most beautiful and iconic sights in our solar system, a vast and delicate system of rings that seems almost too perfect to be real. From a distance, they look like a solid, smooth disk, but they are in fact composed of billions upon billions of individual pieces of water ice. These particles range in size from tiny dust-like grains to great chunks as large as a house. Each one of these icy fragments is a tiny, individual moon, following its own perfect circular path around Saturn, all held together in a great, flat, and shimmering sheet by the planet's immense gravity. The rings are incredibly thin in proportion to their width, like a sheet of paper the size of a great city. They are a silent, glittering river of ice, forever circling a distant, golden world in a state of perfect, weightless, and peaceful suspension. It rains diamonds deep within the atmospheres of Neptune and Uranus. On these cold, distant, and mysterious ice giants, the conditions are unlike anything on Earth. Their atmospheres are thick with hydrogen, helium, and methane. Deep beneath the cloud tops, the pressure and temperature become immense, so extreme that they can break apart the methane molecules. This releases the carbon atoms, which are then crushed together by the incredible pressure. This process, scientists believe, forms solid diamonds, which then, being heavier than their surroundings, slowly rain down through the deep, slushy atmospheric layers of the planets. It is a beautiful and wondrous thought, a slow, silent, and steady rain of precious jewels falling through the dark, deep, and hidden interior of a distant world. A quiet and hidden treasure on a truly planetary scale. The sun's light takes over 8 minutes to travel through space to warm your face. The warmth you feel on your skin on a sunny day is a message from the past. The photons of light that are reaching you in this very moment began their journey from the surface of the sun over 8 minutes ago. They have traveled across 93 million miles of the cold, silent vacuum of space to complete their journey here. If the sun were to suddenly and magically disappear, we on Earth would have no idea for another 8 minutes and 20 seconds. We would continue to see it shining, to feel its warmth, blissfully unaware. We are always living in the gentle, time-delayed glow of our star. Every ray of sunlight is a tiny time capsule, a small, warm piece of the recent past, a constant and gentle reminder that even the closest things in the cosmos are separated from us by a vast and silent distance. A day on Venus is longer than its year. Venus is a world of strange and slow rhythms. It spins on its axis incredibly slowly and in the opposite direction to most of the other planets. It takes about 243 Earth days for Venus to complete one full rotation. But it only takes about 225 Earth days for the planet to complete one full orbit around the Sun. This means that a single Venusian day from one sunrise to the next is longer than its entire year. It is a world where the sun rises in the west and sets in the east, and where the slow, languid pace of the day is a far more dominant rhythm than the turning of the seasons. It is a quiet, geological timescale, a world that turns with a deep and profound patience that is almost impossible for us to imagine. The asteroid belt is a vast and mostly empty river of ancient, wandering stones. We often imagine the asteroid belt as a crowded, chaotic field of tumbling rocks, a difficult place for a spaceship to navigate. But the reality is far more quiet and empty. While there are millions of asteroids in this region between Mars and Jupiter, the volume of space they occupy is absolutely immense. The average distance between any two asteroids is over 1 million miles. It is less like a field of rocks and more like a vast, sparse and silent river of cosmic debris. These are the leftover building blocks of the solar system, the pieces that never quite came together to form a planet. Each one is a silent, primordial wanderer, a cold, dark and lonely time capsule from the very birth of our solar system. Mercury, the closest planet to the Sun, has ice hiding in its shadowed craters. It is a world of incredible extremes. The surface of Mercury that is facing the Sun can reach temperatures hot enough to melt lead. Yet, because the planet has almost no axial tilt, there are craters near its poles whose floors are in a state of permanent shadow. They have not seen a single ray of direct sunlight for billions of years. In these incredibly cold and dark places, shielded from the sun's relentless glare, scientists have discovered vast deposits of water ice. It is a beautiful paradox, a world of fire and ice, a planet that holds both the hottest temperatures and some of the coldest shadows in the inner solar system, a place where frozen water can exist just a few miles away from molten metal. Every comet is a visitor from the cold, distant edge of our solar system. Comets are not like the rocky asteroids. They are great, dirty snowballs, loose collections of ice, dust, and frozen gases left over from the formation of the solar system. Most of them spend their lives in a vast, cold, and distant cloud far beyond the orbit of Neptune, called the Oort cloud. But sometimes a small gravitational nudge will send one on a long, slow journey towards the inner solar system. As it gets closer to the Sun, its ice begins to warm and turn directly into gas, creating the beautiful, glowing coma and the long, ethereal tail that stretches for millions of miles behind it. Each one is a silent, graceful messenger from the deep, frozen, and ancient past of our own cosmic backyard. The tallest volcano we know of is not on Earth, but on the quiet, red surface of Mars. Olympus Mons is a shield volcano of truly colossal proportions. It stands nearly 14 miles high, almost 3 times the height of Mount Everest, and its base is so wide it would cover the entire state of Arizona. Its slopes are gentle and gradual. If you were standing on its summit, its base would be far beyond the horizon, and you would not even feel like you were on a mountain. This immense size is possible because Mars has a lower surface gravity and no plate tectonics. On Earth, a volcano is carried away from its source of lava by the moving plates. But on Mars, Olympus Mons was able to sit in one place for millions of years, growing ever larger with each slow, quiet eruption. It is a silent, sleeping giant, a monument to a more geologically active Martian past. Jupiter's moon, Europa, may hold a vast liquid water ocean beneath its icy shell. Europa is a beautiful and mysterious world. Its surface is a bright, crisscrossing network of cracks and ridges, a great planetary-scale puzzle made of water ice. But the data sent back from passing spacecraft suggests something wonderful. Beneath this frozen crust, which may be several miles thick, there is strong evidence for a vast, globe-spanning ocean of liquid salt water. There may be more liquid water in this hidden ocean on Europa than in all of the oceans of Earth combined. It is a dark, cold, and silent ocean but it may be warmed by tidal forces from Jupiter and by hydrothermal vents on its sea floor. It is one of the most promising places in our solar system to search for the possibility of a different, independent origin of life, a quiet, hidden cradle waiting to be explored. The sun sings a low, deep, and constant song that makes its entire surface vibrate. Our sun is not a silent burning ball, it is a resonant sphere of plasma, and the turbulent, convective motion deep within its core creates sound waves. These waves travel up to the surface and cause the entire sun to gently vibrate, to pulse in and out like a great cosmic drum. The pitch of this solar song is incredibly low, far too deep for any human ear to hear, with a single wave taking about 5 minutes to oscillate. By studying these subtle vibrations, a field called helioseismology, scientists can learn about the hidden inner structure of the sun, just as geologists use seismic waves to study the interior of the Earth. Our star is filled with a deep, silent, and ever-present music. Pluto, once a planet, has a great, smooth heart of frozen nitrogen on its surface. When the New Horizons spacecraft flew past Pluto in 2015, it revealed a world of surprising beauty and complexity. The most stunning feature is a vast, heart-shaped plain of frozen nitrogen over 1,000 miles across, named Tombor Regio. This heart is a remarkably smooth and young surface, almost entirely free of craters, suggesting it is geologically active. It is a great, slow-moving glacier of exotic ice, churning and convecting in the faint, distant sunlight. This soft, frozen heart on a tiny, distant world is a beautiful and unexpected discovery, a sign of a vibrant and active life on a body that was once thought to be just a cold, dead, and inactive rock. The Earth is protected by an invisible magnetic shield that dances with the solar wind. Our planet is constantly bathed in a stream of charged particles flowing outwards from the sun, called the solar wind. This wind would, over millions of years, strip away our atmosphere and make life on the surface impossible. But we are protected. The molten iron core of our planet generates a powerful magnetic field that surrounds the Earth like a great, invisible bubble. This magnetosphere deflects the solar wind, sending it streaming harmlessly around our planet. The beautiful shimmering curtains of the aurora borealis and australis are the visible signs of this shield at work, the place where some of those solar particles are funneled down towards the poles and light up the upper atmosphere. It is our planet's quiet, beautiful, and life-sustaining guardian. There are more stars in the universe than there are grains of sand on all of Earth's beaches. Take a moment to imagine every beach on our planet, every desert, every single grain of sand. Now try to imagine that for every one of those tiny grains, there is an entire, massive, burning star somewhere out in the cosmos. The number is so vast it borders on the infinite. Our minds are simply not equipped to grasp such a scale. But we can feel it. We can feel the immense, quiet, and humbling reality that our own sun is just one single, ordinary grain of sand in a cosmic desert of unimaginable size. It is a deeply peaceful thought, a quiet invitation to let go of our own smallness and simply be a part of this immense, glittering whole. The silence in the vacuum of space is more profound and complete than any quiet on Earth. Sound is a vibration that needs a medium to travel through, like air or water. The space between the stars and the planets is a near-perfect vacuum. There is almost nothing there to carry a vibration. This means that even the most violent and energetic events in the cosmos, a star exploding, two galaxies colliding, happen in a state of absolute and total silence. It is a quiet that is deeper and more complete than the stillest night in the deepest cave on Earth. It is the great foundational silence upon which the beautiful, silent light show of the universe is painted. Saturn's moon, Titan, has rivers, lakes, and seas made of liquid methane. Titan is a strange and wonderful world shrouded in a thick, orange, nitrogen-rich atmosphere, thicker than our own. It is so cold on its surface that water is frozen as hard as rock. But at these incredibly low temperatures, other chemicals that we know of as gases, like methane and ethane, can exist as liquids. Spacecraft have mapped the surface of Titan and found a world with a complete and strangely familiar liquid cycle. There are methane clouds, methane rain, and vast, dark, placid lakes, and seas of liquid methane and ethane, particularly near the moon's poles. It is the only other world in our solar system that has a stable liquid on its surface, a quiet, cold, and profoundly alien reflection of our own watery home. We are all made of stardust, the remnants of stars that lived and died long ago. The atoms that make up your body, the carbon in your cells, the oxygen you breathe, the calcium in your bones, were not created on Earth. They were forged in the incredibly hot, high-pressure cores of ancient stars billions of years ago. These stars lived their long, slow lives, and then, in their final moments, they returned their newly created elements to the cosmos, either through the gentle winds of a dying star or the great, explosive fury of a supernova. This enriched dust then gathered together to form a new generation of stars and planets, including our own Sun and our own Earth. You are, in the most literal sense, a child of the stars, a small, temporary, and thinking piece of an ancient, cosmic recycling program. Our entire solar system is drifting through the vast, quiet space of the Milky Way. We feel so stationary, yet we are on a journey of immense speed and scale. Our planet is orbiting the Sun, and the entire solar system, as a single unit, is moving through our local region of the Milky Way galaxy at a speed of over 500,000 miles per hour. We are traveling through a diffuse and gentle medium of interstellar gas and dust, a quiet and mostly empty space between the stars. It is a calm and steady journey on an orbit so vast it takes over 200 million years to complete a single lap. We are all quiet, unknowing passengers on a great, planetary vessel sailing through the silent, starry seas of our home galaxy. Stars are born in vast, cold, and beautiful clouds of dust and gas called nebulae. A star does not begin its life in a place of fire and fury, but in a place of deep, profound, cold, and quiet. Nebulae are immense interstellar clouds light years across, where the density of gas and dust is just slightly higher than the surrounding space. These are the stellar nurseries of the universe. In the coldest, darkest pockets of these clouds, gravity can begin its slow, patient work. It gently encourages the atoms of gas and dust to begin to clump together, to fall inwards on themselves, creating small, dense knots of matter. It is a process of immense and gentle gathering, a slow and quiet inhalation that is the very first step in the creation of a new point of light. It is the universe gathering its breath before a star is born. The Orion Nebula is a great cosmic nursery where thousands of new stars are quietly being born. It is one of the brightest and most beautiful nebulae in our night sky, a fuzzy, luminous patch visible to the naked eye just below the 3 stars of Orion's belt. It is a vast, churning cloud of gas and dust, over 24 light-years across, and it is the closest region of massive star formation to Earth. Within its glowing, cavernous depths, telescopes have revealed thousands of young, hot stars that have just been born. Their brilliant, ultraviolet light is what causes the surrounding gas to glow in beautiful shades of pink and red. It is a dynamic and vibrant place, a great cosmic cradle filled with the soft, new light of infant suns, a beautiful, visible reminder that the universe is in a constant state of renewal and birth. The color of a star tells the story of its temperature, from cool red to brilliant blue-white. The beautiful twinkling colors of the stars in the night sky are not just decorative, they are a direct and accurate thermometer. The coolest stars, which are still incredibly hot by any earthly standard, glow with a soft, gentle, reddish light. A medium temperature star, like our own sun, glows with a bright, yellowish-white light. The very hottest, most massive, and most luminous stars in the universe burn with an intense, brilliant, and almost electric shade of blue. To look up at the night sky and see the different colors of the stars is to see a beautiful and accurate map of their different surface temperatures, a quiet visual story of their fire and their energy. A star is a perfect sphere, balanced between the inward crush of gravity and the outward push of its own light. For its entire life, a star exists in a state of profound and beautiful equilibrium. The immense force of its own gravity is constantly trying to crush it down into an ever smaller point. But the nuclear fusion happening deep in its core is producing a tremendous amount of outward pushing energy and radiation pressure. These two titanic, opposing forces are in a state of perfect, delicate balance. The inward pull and the outward push are matched so precisely that the star can maintain its stable, spherical shape for billions of years. It is a great cosmic balancing act, a long and peaceful stalemate between the force of collapse and the force of light. Our sun will one day swell into a great, gentle red giant. Our star, like all stars, has a finite amount of fuel in its core. In about 5 billion years, it will have fused all the hydrogen in its core into helium. When this happens, its long, stable life will come to an end, and it will begin a new phase. Its core will contract and heat up, and this will cause its outer layers to expand enormously. The sun will swell to over 100 times its current size, its surface will cool, and its color will shift to a deep, ruddy red. It will become a red giant, a vast, luminous, and gentle sphere that will engulf the orbits of Mercury and Venus. It is the quiet, graceful, and inevitable autumn of our own star's long and beautiful life. The end of a small star's life is a beautiful, glowing structure called a planetary nebula. After a star like our sun has passed through its red giant phase, it does not explode. Instead, it gently puffs its outer layers of gas away into space. The tiny, hot, and incredibly dense core of the star, the white dwarf, is left behind. The intense ultraviolet light from this hot core then shines upon the expanding cloud of gas that surrounds it, causing the gas to glow with beautiful, intricate, and often surprisingly complex colors and shapes. These structures, which have nothing to do with planets, are some of the most beautiful objects in the night sky. They are the final, gentle, and artistic sigh of a dying star. The Helix Nebula is so vast it is sometimes called the Eye of God. It is one of the closest and brightest planetary nebulae, the beautiful death shroud of a star that ended its life thousands of years ago. From our perspective on Earth, it looks like a single, great, and multicolored eye staring back at us from across the cosmos. It is a vast and intricate structure with delicate comet-like knots of gas and a beautiful web-like pattern of filaments. To look at an image of the Helix Nebula is to see the beautiful, complex, and final artistic statement of a sun very much like our own, a quiet and humbling glimpse into the far distant future of our own solar system. It is a peaceful, profound, and deeply beautiful vision of a star's final rest. The heaviest elements in the universe are forged in the final, brilliant moments of a supernova. The elements that make our world interesting and complex, things like iron, gold, silver, and platinum, cannot be created in the core of a normal star like our Sun. They require an even more extreme furnace. This furnace is the supernova, the explosive death of a very massive star. In the final, catastrophic moments of the star's collapse and subsequent explosion, the temperatures and pressures become so incredibly high that these heavy elements can be forged. The great, expanding shockwave of the supernova then scatters these newly created precious metals out into the surrounding space, seeding the next generation of clouds that will form stars and planets. Every piece of gold on Earth is the rare and beautiful ash of an ancient, exploded star. A supernova can briefly outshine its entire home galaxy. The amount of energy released in the death of a single massive star is almost beyond comprehension. For a few short weeks, the light from that one single exploding star can be as bright, or even brighter, than the combined light of the hundreds of billions of other stars in its entire galaxy. If a supernova were to happen in our own Milky Way, it would be visible in our daytime sky and would be the brightest object in the night sky besides the moon. It is the universe's most spectacular and brilliant firework, a brief, magnificent and solitary flash of light that announces the end of one great life and the seeding of countless new ones. The remains of a supernova can leave behind a delicate, expanding web of gas called a remnant. After the brilliant flash of the supernova has faded, the story is not over. The material that was blasted out into space continues to expand outwards for thousands of years, creating a beautiful, intricate, and ghostly structure called a supernova remnant. These are some of the most stunningly beautiful objects in the cosmos. The Crab Nebula, for example, is a tangled, glowing web of filaments from a supernova that was seen on Earth in the year 1054. These remnants are the visible, fading echoes of a great cosmic event, a quiet and beautiful memorial to a star that once was. Some stars are so large they could swallow the orbit of Jupiter. Our Sun is a relatively average-sized star, but there are other stars in the universe called hypergiants that are of a truly colossal scale. The star UY Scuti, for example, is one of the largest known. If you were to place it at the center of our solar system, its surface would extend out past the orbit of Jupiter. It is a vast, diffuse, and incredibly luminous object. These stars are very rare and live very short, dramatic lives. They are the great, gentle giants of the cosmos, living their lives on a scale of size and brightness that is difficult for the human mind to truly hold. A white dwarf is the small, incredibly dense cooling heart of a star that has run out of fuel. When a star like our Sun has finally shed its outer layers as a planetary nebula, what is left behind is its core. This core, a white dwarf, is an object of incredible density. It has the mass of our Sun, but it has been crushed down into a sphere that is only about the size of the Earth. It no longer produces any new energy. It is like a glowing cosmic ember, a hot, dense ball of carbon and oxygen that will spend the next trillions of years slowly and quietly radiating its stored heat away into the cold of space, until it eventually becomes a cold, dark, and invisible black dwarf. It is the long, slow, and peaceful process of a star's final cooling. A teaspoon of a white dwarf would weigh as much as an elephant. This is a quiet way to appreciate the incredible density of these stellar remnants. On Earth, atoms are mostly empty space, but inside a white dwarf, the inward crush of gravity is so immense that the atoms themselves are crushed. The electrons are stripped away from their nuclei, forming a strange and super-dense state of matter called degenerate matter. This is why a white dwarf can pack so much mass into such a small volume. It is a star that has been compressed down to the absolute limit of what matter can withstand, a quiet and profound testament to the overwhelming power of gravity. Most stars exist in pairs, locked in a silent gravitational dance with a companion. We tend to think of our Sun as typical, a a solitary star journeying through space alone. But it is actually something of a rarity. Most stars in the galaxy are part of a binary or multiple star system. They are born together from the same swirling cloud of gas and spend their entire lives orbiting a common center of gravity. This is a quiet and graceful celestial waltz, a partnership that can last for billions upon billions of years. Some pairs are so far apart that their orbital dance takes 1,000 years to complete one turn. Others are so close that their atmospheres touch and mingle, a constant silent stream of stellar material passing from one to the other. To look up at the night sky is to see a sky not of lonely individuals, but of countless cosmic companions, each one locked in a gentle, gravitational embrace with its partner, a quiet testament to the power of connection, even on a stellar scale. The Pleiades, or Seven Sisters, is a beautiful, young cluster of stars still shrouded in its birth nebula. It is one of the most recognizable and beautiful objects in the night sky, a small, glittering cluster of bright blue stars that looks like a tiny, diamond-studded dipper. These are young, hot, and massive stars, born together from the same great cloud of gas and dust only about 100 million years ago. They are cosmic siblings, still traveling together through space before they eventually drift apart over the coming eons. In long exposure photographs, the Pleiades are revealed to be embedded in a delicate, wispy, and ethereal blue cloud. This is a reflection nebula, the leftover dust from their own birth cloud, its fine particles perfectly scattering the blue light from these young, brilliant stars. It is like looking at a beautiful, newborn family still wrapped in the soft, glowing blanket of their own cosmic cradle. Some ancient stars, called globular clusters, are like great glittering cities of 1,000,000 suns. If a young cluster like the Pleiades is a small, bright village, then a globular cluster is a vast and ancient metropolis. These are huge, perfectly spherical collections of hundreds of thousands or even millions of very old reddish stars, all tightly packed together by their mutual gravity. They orbit in the faint outer halo of our galaxy like great, silent satellites. The stars in the center of a globular cluster are packed so densely that the night sky there would be an unimaginable spectacle, a sky filled with thousands of brilliant suns, some appearing as bright as our own full moon. These are the ancient elders of our galaxy, serene and glittering collections of the very first stars to be born, holding the quiet, patient wisdom of nearly the entire age of the universe. A brown dwarf is a star that never quite ignited, a warm but dark wanderer in space. In the great process of star formation, some clumps of gas are not quite massive enough to begin the process of nuclear fusion in their cores. These are the brown dwarfs, the failed stars of the universe. They are larger than a planet like Jupiter, but smaller than the smallest true star. They do not shine with their own created light, but they do glow faintly with the residual heat from their own formation, a dim, deep, magenta red light that is mostly invisible to our eyes. They are the quiet, warm, and lonely wanderers of the galaxy, the almost stars, the gentle tweeners of the cosmos, forever drifting through the dark with only their own quiet, fading warmth to keep them company. They are a soft and gentle reminder that not every beginning leads to a brilliant fire. The light of a star can travel for millions of years in a perfectly straight line through the void. A photon of light, once it is created in the heart of a star and released from its surface, begins a journey of incredible purity. It travels through the near-perfect vacuum of intergalactic space, and unless it passes very close to a massive object, its path will be an absolutely, perfectly straight line. It does not waver, it does not tire, it does not slow down. It is a perfect, tiny messenger, faithfully carrying its information across unimaginable distances and timescales. The light from the Andromeda galaxy that might reach your eye tonight has been on such a journey For 2.5 million years, a straight, silent, and unbroken path through the deep, cosmic dark. A testament to the simple, elegant, and unwavering nature of light itself. Every star you see in the night sky is bigger and brighter than our own sun. It is a simple and humbling fact of perspective. Our sun is a relatively average, even modest star, but it is so incredibly close to us that it appears as a great, brilliant, life-giving orb. The other stars we can see with our naked eye are all, without exception, intrinsically much larger and more luminous than our sun. They appear as tiny, faint points of light only because they are so incredibly far away. If our own sun were placed at the distance of even the closest of these stars, it would be completely invisible to us. The beautiful, glittering stars of our night sky are the true giants of our galactic neighborhood. Their immense and brilliant light softened into gentle, peaceful twinkles by the vast, quiet cushion of interstellar distance. The life of a star is a slow, graceful, and predictable journey from dust to light and back to dust. While the details may vary, the great story of every star is a simple and beautiful one. It begins as a slow, gentle gathering of cold, dark dust and gas. It ignites into a long and stable life of shining, a peaceful, middle-aged period that can last for billions of years. And then, it ends its life by returning its substance back to the cosmos, either through a gentle, puffing release or a brilliant, explosive one. This stardust then mixes with the great clouds, ready to begin the cycle all over again. It is a perfect cosmic circle of life, a slow, patient, and deeply reassuring story of birth, of shining, and of a quiet, generative return to the whole. Our home, the Milky Way, is a great, flat, spiral city of over 200 billion stars. It is almost impossible to hold a number like that in our minds, so let us imagine it differently. Imagine our galaxy as a vast and silent river of light, a great, slowly turning whirlpool of stars, gas, and dust. It has a bright, dense, golden center, a galactic core where millions of stars are crowded together. From this center, several graceful spiral arms unfold, each one a flowing current of younger, blue-white stars and beautiful, pinkish nebulae. We live in one of these quiet suburban arms about 2/3 of the way out from the bustling center. Our view of the Milky Way from Earth is the view from within this river, looking across it to see a beautiful, hazy, and shimmering band of countless distant suns stretching across our night sky. It is our quiet, vast, and beautiful home. At the center of our galaxy lies a supermassive black hole, holding everything in a quiet, gravitational embrace. At the very heart of our great starry river, there is a point of incredible stillness and immense power. It is a supermassive black hole, an object with the mass of over 4 million of our suns, all contained within a space smaller than the orbit of Mercury. We cannot see it, but we can see the stars that orbit it, whipping around this invisible point at incredible speeds. This quiet central anchor is the gravitational heart of our galaxy. Its immense, gentle, and steady pull is what orchestrates the great, slow, and graceful rotation of the entire Milky Way. It is not a monster, but a quiet, unseen shepherd, holding its vast flock of stars together in a single, beautiful and coherent family. It takes our sun over 200 million years to complete one orbit of the Milky Way. This vast and almost unimaginable span of time is known as a cosmic year. The last time our solar system was in this same position in its great galactic journey, the dinosaurs were just beginning to appear on Earth. The time before that, the world was a very different and alien place. We are all on a slow, majestic, and silent carousel, a journey so vast and so patient that all of human history is but a tiny, fleeting moment within a single one of its laps. It is a deeply calming and peaceful thought. to feel ourselves as part of a motion that is so grand, so ancient, and so unhurried. The Andromeda Galaxy is our closest large neighbor, and it is slowly drifting towards us. When you look up at the autumn sky, you can just make out a faint, fuzzy, and elongated patch of light. This is the Andromeda Galaxy, a sister spiral galaxy very similar to our own, but even larger. It is the most distant object you can see with your unaided eye, and its light has been traveling for 2.5 million years to reach you. And in that entire time, it has been getting closer. Pulled by mutual gravity, our Milky Way and Andromeda are slowly, but inevitably, drifting towards each other at a speed of over 250,000 miles per hour. In about 4 billion years, they will begin a long, slow, and graceful process of merging, a silent, cosmic dance that will eventually form a single, new, and even larger galaxy. When two galaxies collide, they rarely have stars that hit each other. They simply pass through one another like ghosts. The distances between the stars within a galaxy are so incredibly vast that when two galaxies merge, the chance of any two individual stars actually colliding is almost zero. Instead, the two great starry structures will pass through each other, their shapes distorted and pulled into long, beautiful tidal streams by their mutual gravity. It is a slow-motion collision that takes hundreds of millions of years to unfold. It is not an act of destruction, but an act of creation, a graceful and silent merging of two great stellar families into one, a process that triggers a great burst of new star formation, creating a new and more vibrant home for the future. Some galaxies are not spirals, but great, smooth, elliptical clouds of ancient stars. Not all galaxies have the beautiful pinwheel structure of our own Milky Way. Many of the largest galaxies in the universe are ellipticals. These are vast, three-dimensional, football-shaped swarms of stars, often containing trillions of suns. They are thought to be the result of many previous galactic mergers. They are typically much older than spiral galaxies and are filled with ancient reddish stars with very little gas or dust left to form new ones. They are the great old and quiet cities of the universe, the calm, settled, and mature elders of the cosmic community, their bright, youthful days of active star formation long since past. The Sombrero Galaxy looks like a vast, celestial hat, its bright core surrounded by a dark lane of dust. It is one of the most striking and beautiful galaxies we have ever photographed. We see it almost perfectly edge-on, giving it its distinctive shape. It has a huge, brilliant, and unusually large central bulge of old yellow stars. Surrounding this bright core is a flat, spinning disk, just like in our own galaxy. But because we see it from the side, this disk appears as a single, dark, and dramatic line of interstellar dust, silhouetted against the bright light of the core behind it. It is a perfect cosmic coincidence of orientation, a galaxy that seems to have posed for us in its most beautiful and mysterious profile. Galaxies are not scattered randomly, but are arranged in a vast web-like structure throughout the universe. If you could zoom out and see the entire observable universe at once, you would see a structure of breathtaking beauty and complexity. The galaxies are not spread out like a uniform fog. They are arranged in a great, three-dimensional network that is often called the cosmic web. This web is made of long, thin, glowing filaments, like the threads of a great cosmic spiderweb, and at the intersections of these filaments are dense, bright clusters where thousands of galaxies are gathered together. It is the largest and most serene structure in all of nature, a silent, glittering, and interconnected web that stretches for billions of light years in every direction. This cosmic web is made of long filaments of galaxies separated by immense, quiet voids. In between the glowing threads of the cosmic web are the great cosmic voids. These are vast, dark, and almost completely empty regions of space. They are immense, spherical bubbles of near-nothingness, hundreds of millions of light-years across. While the filaments are the bustling highways and cities of the universe, the voids are the great, silent, and peaceful countryside. A galaxy that happened to exist in the middle of one of these voids would have a night sky that is almost completely dark, with no other galaxies visible at all. The universe, on its grandest scale, is a place of beautiful, stark contrast between the something and the almost nothing. Our Milky Way is part of a small gathering of galaxies called the Local Group. We are not alone in our corner of the universe. Our Milky Way is one of the two largest members of a small, gravitationally bound collection of over 50 galaxies. The other large member is the Andromeda Galaxy. The rest are a collection of smaller dwarf galaxies, many of which are in quiet, gentle orbits around their two larger hosts. The Local Group is our extended galactic family, our small and relatively peaceful neighborhood in the vast cosmic city. It is a small, quiet island of matter drifting together through the much larger and emptier spaces of the universe. The Local Group is, in turn, part of the even larger Virgo supercluster. If we zoom out even further, we find that our Local Group is not isolated. It is on the very outer edge of an even larger structure, a great swarm of thousands of galaxies known as the Virgo supercluster. At the heart of this supercluster, some 65 million light-years away, is the Virgo cluster, a dense and massive collection of over 1,000 galaxies. All of the galaxies in our supercluster, including our own, are feeling the gentle, persistent, and long-range gravitational pull of this great central cluster. We are all, in a sense, slowly and quietly falling towards Virgo, like 1,000 silent rivers all flowing towards the same great cosmic sea. The Hubble Deep Field is a photograph of a tiny, empty patch of sky revealing thousands of distant galaxies. In 1995, astronomers pointed the Hubble Space Telescope at a single, dark, and seemingly completely empty patch of the night sky, a spot no bigger than a grain of sand held at arm's length. They left the shutter open for over 100 hours, gathering the faintest, most ancient light imaginable. The resulting image is one of the most profound in human history. That tiny, empty patch of sky was revealed to be filled with over 3,000 distant galaxies, each one a fuzzy, faint smudge of light, an entire island universe of billions of stars. It was a deep and humbling look into the true scale of the cosmos, a quiet and beautiful reminder that the universe is filled to the brim with wonders. Even in its darkest and most empty-seeming corners, some galaxies have brilliant, active cores called quasars that outshine everything else. In the early universe, when galaxies were young, many of them had incredibly bright and energetic centers. These are known as quasars. A quasar can be so luminous that it outshines the combined light of all the hundreds of billions of stars in its own host galaxy. This incredible energy is not coming from stars. It is coming from the supermassive black hole at the galaxy's center. As vast amounts of gas and dust fall in towards the black hole, they form a swirling, superheated disk that glows with an unimaginable brilliance. A quasar is the beautiful and brilliant beacon that signals the presence of a young, growing, and well-fed black hole at the heart of a distant galaxy. The light from the most distant galaxies has been traveling towards us for over 13 billion years. Because light travels at a finite speed, to look out into space is to look back in time. The further we look, the further back in time we see. With our most powerful telescopes, we can now see galaxies as they were when the universe was just a few 100 million years old, a mere toddler in cosmic terms. The light from these first, primitive galaxies is ancient and faint. It has been traveling across the expanding universe for almost the entire age of time itself. To see these galaxies is to see our own cosmic origins, a quiet and blurry photograph of the universe in its earliest and most formative moments. There are dwarf galaxies with only a few million stars, orbiting our own like tiny moons. The story of galaxies is not just a story of giants like our Milky Way. It is also a story of the small and the humble. Our galaxy is surrounded by a swarm of dozens of much smaller dwarf galaxies. Some of these, like the Large and Small Magellanic Clouds, are visible from the southern hemisphere as faint, cloud-like patches in the night sky. Many are much fainter, little more than sparse, ghostly collections of a few million stars. They are in a long, slow gravitational dance with our much larger galaxy, and over billions of years, many of them will be gently and quietly pulled apart and absorbed into the great, starry river of the Milky Way. Gravitational waves are silent ripples in the fabric of space-time itself, caused by colliding black holes. Imagine dropping two stones into a perfectly still cosmic pond. The ripples that spread out are not moving through the water. They are the water itself, rising and falling. In the same way, when two incredibly massive objects like black holes or neutron stars spiral into each other in a final, cataclysmic dance, they disturb the very fabric of reality. This disturbance spreads outwards, not as light or sound, but as a gentle stretching and squeezing of space and time. These waves travel for billions of years across the universe at the speed of light, carrying the silent news of that ancient collision. When they finally wash over the Earth, they stretch and squeeze everything they pass through by an amount smaller than the width of an atom. They are the faintest, most profound, and most silent whispers in the entire universe, a new way for us to listen to the deep, resonant music of the cosmos. Dark matter is an invisible, mysterious substance that acts as the gravitational scaffolding for galaxies. When astronomers look at galaxies, they see a beautiful and profound puzzle. The stars on the outer edges of spiral galaxies are spinning much too fast. According to the gravity of the visible matter we can see, these stars should be flung off into intergalactic space, but they are not. They are held in place by an extra, unseen gravity. This has led scientists to believe that galaxies are embedded within a vast, spherical halo of a mysterious, invisible substance called dark matter. We do not know what it is made of, but we know it is there. It does not shine, it does not reflect light, it does not interact with us in any way except through its gentle, persistent, and powerful gravitational pull. It is the quiet, unseen, and foundational architecture of the cosmos, the invisible skeleton upon which the beautiful, shining body of a galaxy is built. We cannot see dark matter, but we can see the way its gravity bends the light of distant stars. Although dark matter itself is completely invisible, its presence can be mapped by its effects on the things we can see. Just as a glass lens bends light, the immense gravity of a clump of dark matter can bend the fabric of space-time. When the light from a very distant galaxy passes through one of these invisible halos of dark matter on its way to us, its path is curved. We see the image of the distant galaxy as distorted, stretched, or even multiplied into several images. This phenomenon, called gravitational lensing, allows astronomers to create a map of this unseen substance. It is like seeing the location of invisible stones at the bottom of a river by watching the way the currents of water, or in this case light, are bent as they flow over them. It is a way of seeing the unseen, using light as our quiet and faithful guide. Dark energy is a gentle, repulsive force that is causing the expansion of the universe to speed up. For most of the 20th century, astronomers assumed that the expansion of the universe, which began with the Big Bang, must be slowing down, held back by the mutual gravitational pull of all the galaxies. But in the late 1990s, they made a shocking and profound discovery. By looking at very distant supernovae, they found that the expansion is not slowing down at all. In fact, it is accelerating. The universe is expanding faster and faster with each passing moment. To explain this, scientists have proposed the existence of a mysterious, gentle, and repulsive force that is inherent to the fabric of space itself. This is dark energy. It is a quiet, persistent, and anti-gravitational push that is slowly and steadily winning the great cosmic tug-of-war against gravity, gently driving the galaxies further and further apart. A magnetar is a type of neutron star with a magnetic field so powerful it is almost beyond comprehension. A magnetar is one of the most extreme and exotic objects in the entire universe. It is a type of neutron star, an incredibly dense, city-sized remnant of a supernova. But a magnetar also has a magnetic field of a truly mind-boggling intensity, hundreds of trillions of times stronger than the Earth's magnetic field. This field is so powerful that it would be lethal to a human from hundreds of thousands of miles away. It is so strong that it can cause the solid, crystalline crust of the neutron star to buckle and crack, creating immense starquakes. These events can release vast, powerful bursts of gamma rays, the most energetic form of light. A magnetar is a quiet and terrifyingly powerful magnetic engine, a small, spinning object that possesses one of the strongest and most potent forces in the entire cosmos. Quasars are powered by supermassive black holes feeding on gas at the centers of young galaxies. A quasar, which stands for quasi-stellar radio source, is a beacon of incredible brilliance, shining at us from the very dawn of cosmic time. From Earth, they can look like a single, bright star, but they are in fact the ferociously active cores of very young, very distant galaxies. The source of this incredible light is the supermassive black hole at the galaxy's heart. In the early universe, there was an abundance of gas and dust available to fall into these black holes. As this material spirals inwards, it forms a vast, superheated, and intensely luminous accretion disk, a whirlpool of matter that is being heated to millions of degrees before it takes its final plunge. A quasar is the brilliant, beautiful, and temporary bonfire that is lit as a galaxy's central black hole enjoys a great and powerful feast, a gravitational lens occurs when a massive galaxy bends the light of a galaxy behind it into a beautiful ring or cross. Sometimes, the alignment of objects in the deep cosmos can create a spectacle of breathtaking and accidental beauty. If a large galaxy lies directly between us and an even more distant galaxy, the gravity of the foreground galaxy can act like a giant natural telescope lens. It bends the light from the background object around itself. If the alignment is perfect, this bent light can appear to us as a perfect, glowing circle of light, known as an Einstein ring. It looks like a golden celestial halo, a perfect circle of ancient light from a distant galaxy, wrapped perfectly around its nearer companion. If the alignment is slightly off, it can create multiple, distinct images of the same background object, sometimes in a beautiful cross-like pattern. It is a quiet cosmic illusion, a beautiful trick of light and gravity. The vacuum of space is not truly empty, but simmers with a faint energy of its own. In our classical understanding, a perfect vacuum is a place of true nothingness, a void that is completely empty of all matter and energy. But according to the strange and wonderful laws of quantum mechanics, this is not the case. Even in the most perfect vacuum at the coldest possible temperature, there is a constant, simmering, and irreducible background energy. This is called vacuum energy or zero-point energy. It is a place where pairs of virtual particles are constantly popping into and out of existence in moments too brief to measure. The empty space of the universe is not a quiet, dead, and passive stage. It is a dynamic, shimmering, and energetic medium, a place where there is a constant, quiet fizz of potential, even in the deepest and most profound of silences. Most of the universe is made of these two deep mysteries, dark matter and dark energy. After all of our centuries of looking at the beautiful, shining objects in the sky, we have come to a humbling and profound conclusion. The stars, the galaxies, the gas, and the dust, all the things that we can see and touch and understand, make up only about 5% of the total mass and energy content of the universe. The other 95% is made up of these two mysterious, invisible, and deeply strange substances. About 27% is dark matter, the invisible scaffolding that holds the galaxies together. And about 68% is dark energy, the gentle, repulsive force that is driving the universe apart. Our beautiful, luminous cosmos is just a small, decorative foam on the surface of a vast and deep ocean of the unknown. A rogue planet is a world that wanders through the darkness of space, not orbiting any star. Not all planets are tethered to a sun. It is thought that there may be billions of planets in our galaxy that were ejected from their home solar systems during their chaotic formation. These are the rogue planets, the lonely cosmic wanderers. They travel through the vast, cold, and dark spaces between the stars, with no sun to warm them and no light to illuminate them. They are worlds of perpetual starlit night. It is a lonely and poetic image, but they may not be entirely dead. A large gas giant rogue planet could have a warm core and could be orbited by its own moons, which might have liquid water oceans under their ice, warmed by the planet's internal heat. They are the silent, hidden, and homeless worlds of the cosmos. Black holes do not suck things in. They are regions where space itself is flowing inward like a river. The common image of a black hole as a cosmic vacuum cleaner is a misleading one. The gravity of a black hole from a safe distance is no different from the gravity of a star of the same mass. The true wonder and strangeness of a black hole is not in its pull, but in its effect on the shape of space-time itself. Imagine a wide, slow-moving river. This is space. Now imagine this river flows towards a great steep waterfall. This is the black hole. The closer you get to the waterfall, the faster the water itself is flowing. The event horizon is the point where the current of the water, or in this case the current of space itself, is flowing inward faster than you could possibly swim, or faster than light can travel. It is not an object that pulls you, but a current that carries you away. The universe is filled with a quiet, invisible weather of these strange and powerful forces. We are used to the idea of weather on Earth, the wind, the rain, the clouds. But there is a different, deeper, and more silent kind of weather that permeates the entire cosmos. It is the weather of space-time itself. It is the gentle, constant rain of dark matter particles passing harmlessly through us. It is the steady, anti-gravitational wind of dark energy pushing the galaxies apart. It is the occasional faint and passing storm of gravitational waves from a distant cosmic collision. We cannot feel this weather, we cannot see it, but it is the true, underlying and fundamental environment in which our entire luminous universe exists. It is the deep, quiet and invisible climate of reality itself. These mysteries are not problems, but quiet invitations to wonder and to dream. The fact that we do not know what dark matter or dark energy are is not a failure of science. It is its greatest and most beautiful opportunity. These deep and profound mysteries are the universe's way of inviting us to think more deeply, to imagine more freely, and to look at the cosmos with a renewed sense of awe and wonder. They are a quiet and humbling reminder that our knowledge is just a small island in a vast and beautiful ocean of the unknown. They are not a cause for frustration, but a profound and peaceful reason to continue the gentle, endless journey of discovery. The universe is far more strange and far more beautiful than our eyes alone can see. Our eyes are wonderful instruments, but they are sensitive to only a tiny, narrow sliver of the full reality of the cosmos. We cannot see the radio waves from a distant pulsar, the infrared light from a cool brown dwarf, or the X-rays from a black hole's accretion disk. And we certainly cannot see the gentle gravitational presence of dark matter or the subtle, repulsive push of dark energy. The universe that is revealed to us by our modern instruments is a place of incredible, multi-layered, and mostly invisible beauty. To truly appreciate the cosmos is to learn to see it not just with our eyes, but with the quiet, open, and wondering eye of our mind. When you look at the stars, you are looking into the past as their light has taken years to reach you. This is one of the most simple and yet most profound truths of the cosmos. The speed of light, while immense, is finite. This means that the light from every single object in the night sky has taken time to travel to us. The light from the closest star system, Alpha Centauri, has been traveling for over 4 years. The light from the Polaris, the North Star, has been on its journey for over 400 years. The light from the Andromeda Galaxy for 2.5 million years. The night sky is not a snapshot of the universe as it is now. It is a beautiful, layered, and multi-temporal collage, a deep cosmic photograph made of light of 1,000 different ages. To look up is to be a quiet and peaceful time traveler. The cosmic microwave background is the oldest light in the universe, a gentle, fading echo of the Big Bang. No matter where we point a radio telescope in the sky, we can detect a faint, cool, and almost perfectly uniform glow of microwave radiation. This is not light from any star or galaxy. It is the universe's own baby picture. It is the afterglow of the moment, about 380,000 years after the Big Bang, when the universe had cooled enough for the first atoms to form, and light was finally set free to travel through space unimpeded. This ancient light, the very first light, has been traveling and cooling and stretching with the expansion of the universe ever since. It is a gentle, persistent, and beautiful whisper from the very dawn of time, a quiet and profound connection to our own cosmic beginning. The universe began not in a loud explosion, but in a silent, hot, and dense state that has been expanding ever since. The term Big Bang can be a misleading one. It suggests a chaotic, noisy explosion happening in a pre-existing empty space. The reality is more subtle and more profound. The Big Bang was the beginning of space and time themselves. It was an initial state of incredible heat, density, and energy from which the fabric of space-time itself began to expand. It was not an explosion in space, but an expansion of space everywhere at once. It was a silent, graceful, and perfectly orderly unfolding of the universe, governed by the beautiful and precise laws of physics, a quiet and smooth beginning to the great cosmic story. For the first 380,000 years, the universe was a dense, glowing fog with no stars or galaxies. In the early moments of the universe, it was so hot and so dense that atoms could not form. It was a sea of free-floating protons, neutrons, and electrons, and light was constantly being scattered by these charged particles. The entire universe was an opaque, glowing, and featureless fog, like being inside the sun. You would not have been able to see any further than a few feet in front of you. It was only when the universe had expanded and cooled to a temperature of about 3,000 degrees that the first stable, neutral atoms of hydrogen could form. This was a moment of profound transformation. The fog cleared, the universe became transparent, and the first light was set free on its long journey. It was the moment of the universe's first sunrise. The expansion of the universe is not happening in space, it is the stretching of space itself. This is another subtle but deeply important idea. We can imagine the universe as the surface of a great expanding balloon. The galaxies are like dots drawn on this surface. As the balloon is inflated, all the dots move further away from each other, but the dots are not sliding across the rubber. It is the rubber itself, the very fabric of space, that is stretching and creating more distance between them. This is why some very distant galaxies can be receding from us faster than the speed of light. They are not traveling through space that fast, but the space between us and them is stretching at that incredible rate. It is a quiet, gentle, and universal process of creation. Every point in the universe can feel like it is the center of this gentle, cosmic expansion. Because it is space itself that is expanding, there is no single, privileged center to the universe. From our vantage point in the Milky Way, it seems as though all the other galaxies are rushing away from us. But this is an illusion of perspective. If we were standing in any other galaxy, we would see the exact same thing. We would see all the other galaxies, including our own Milky Way, rushing away from us. Every point is the center of its own observable universe. It is a profoundly democratic and peaceful idea, a quiet and cosmic reminder that there is no special or important place in the great, unfolding tapestry of the cosmos. The universe is cooling and becoming less dense as it gets older. The story of the universe since the Big Bang has been a long, slow, and steady story of cooling and expansion. From an initial state of almost infinite heat and density, it has been expanding and thinning out for 13.8 billion years. It has gone from a state of pure, simple, and undifferentiated energy to a state of cool, complex, and beautiful structure. It is like a great, single breath that is still being exhaled. This process of cosmic cooling is what has allowed for the formation of all the beautiful things we see: atoms, stars, galaxies, and life itself. Each new, cooler state has allowed for a new and more complex layer of beauty to emerge. The laws of physics appear to be the same in every direction and in every corner of the cosmos. This is a simple, beautiful, and profoundly important observation. The light from a distant galaxy, billions of light years away, tells us a remarkable story. It tells us that the properties of an atom of hydrogen in that distant galaxy are exactly the same as the properties of an atom of hydrogen here on Earth. It tells us that the force of gravity works in the same way, and that the speed of light is the same constant. The fundamental rules of the cosmic game appear to be universal. There is a deep, quiet, and reassuring sense of order and consistency to the entire universe. A single, elegant set of laws that governs everything, everywhere. The light from a distant star carries the chemical signature of that star's atmosphere. When the light from a star passes through its own outer atmosphere, the different elements in that atmosphere absorb very specific colors or wavelengths of light. When we on Earth capture that starlight and spread it out into a rainbow or a spectrum, we can see a series of dark lines. These lines are a perfect, unique, and unmistakable fingerprint that tells us exactly which elements are present in that star's atmosphere. It is a beautiful and powerful form of cosmic alchemy. We can know the chemical composition of an object that is trillions of miles away simply by reading the quiet, silent story that is written in its ancient light. The atoms in your body were created in the hearts of stars that existed long before our sun. Take a moment to consider your own hand. The carbon, the nitrogen, the oxygen, all the elements heavier than hydrogen and helium that make up your very being, have a long and wondrous history. They were not created on this planet. They were forged in the immense heat and pressure of the nuclear furnaces at the cores of ancient, massive stars. These stars lived their lives, and then, in their final, explosive moments, they scattered these precious, newly minted atoms across the galaxy like a farmer scattering seeds. This enriched stardust then became part of a new cloud, which collapsed to form our own solar system. You are, in the most profound and literal sense, a piece of the cosmos that has become aware of itself. There are planets orbiting other stars, some of which may be like our own Earth. For all of human history, we knew of only one set of planets, the ones in our own solar system. But in the last few decades, we have made a profound and beautiful discovery. We now know that planets are incredibly common. It seems that almost every star in the galaxy has its own family of orbiting worlds. We have found thousands of these exoplanets. We have found gas giants larger than Jupiter and small, rocky worlds that may be similar to Earth. Some of these are in the habitable zone of their star, the gentle, temperate region where liquid water could exist on their surfaces. The night sky is not just a sky of distant suns. It is a sky of countless, unseen, and quiet worlds. The universe has no discernible edge and no center. It is a natural human impulse to ask what is at the edge of the universe or what is beyond it. But these questions may not have a meaning. According to our best understanding, the universe is not an object sitting in a larger, empty space. The universe is all of space. It may be that it is infinite, stretching on forever in every direction. Or it may be that it is finite but has a curved geometry, so that if you traveled in a straight line for long enough, you would end up right back where you started, like walking on the surface of a great four-dimensional sphere. In either case, there is no wall, no boundary, no edge to be found. It is a place of boundless and peaceful continuity. The story of the universe is a story of increasing complexity, from simple particles to stars, galaxies, and life. The early universe was a very simple place. It was a smooth, hot, and almost perfectly uniform soup of fundamental particles. But as it has expanded and cooled, it has developed an incredible richness and complexity. The simple particles clumped together to form the first atoms. These atoms gathered to form the first stars. These stars gathered to form the first galaxies. And on at least one planet, orbiting at least one star, in at least one galaxy, this process of increasing complexity has led to the strange, beautiful, and wonderful phenomenon of life and consciousness. It is a quiet, patient, and 13.8 billion year long story of cosmic emergence. The deep quiet of the night sky is a direct consequence of the universe having a finite age. This is a simple question with a profound answer. Why is the sky dark at night? If the universe were infinitely old and infinitely large and filled with stars, then no matter where you looked in the sky, your line of sight would eventually end on the surface of a star. The entire night sky should be as bright as the surface of the sun. The fact that it is not, the fact that we are surrounded by a cool, dark, and peaceful blackness, is a direct proof that the universe is not infinitely old. The darkness of the night sky is the darkness of the time before the first stars were born, a quiet and beautiful window into the deep, cosmic past. Time and space are not separate things, but two parts of a single, unified fabric called space-time. For most of human history, we imagined space as a great three-dimensional stage and time as a separate, universal clock ticking away for everyone. But Einstein showed us a deeper and more beautiful truth. He showed that space and time are inextricably woven together into a single, four-dimensional continuum. You cannot move through one without affecting your journey through the other. The faster you move through space, the slower you move through time. The shape of this fabric is what we feel as gravity. It is the single, dynamic, and flowing substance in which all of the events of the universe unfold. The color of distant galaxies is stretched and reddened by the expansion of the universe. As the light from a very distant galaxy travels towards us, the fabric of space that it is traveling through is constantly stretching. This stretching has a direct and beautiful effect on the light itself. It stretches the wavelength of the light, shifting it towards the red end of the spectrum. The further away a galaxy is, the longer its light has been traveling, and the more the universe has expanded during that journey, so the more its light is redshifted. This cosmic redshift is the primary piece of evidence for the expansion of the universe. It is the quiet, colorful signature of a universe that is constantly and gently growing. The universe is a vast, interconnected system unfolding with a slow, patient, and cosmic logic. From the tiniest quantum fluctuation to the largest supercluster of galaxies, everything is a part of a single, unified, and evolving story. The laws that govern the falling of an apple are the same laws that govern the orbiting of the stars. The atoms forged in an ancient supernova are the same atoms that are breathing in your lungs right now.
There is no separation.
Everything is a part of everything else. It is a deeply peaceful and reassuring thought to feel oneself as a small but integral part of this single, vast, and beautifully logical cosmic unfolding. Our existence is a brief, wonderful moment of awareness in the great silent story of the cosmos. For almost all of its 13.8 billion-year history, the universe has been unaware of its own beauty. It has been a story without a reader. The evolution of life and of consciousness is a new and wonderful chapter in this story. We are a way for the universe to know itself. Our brief moments of awareness, our ability to look up at the night sky and feel a sense of awe and wonder, are one of the most precious and beautiful phenomena in the entire cosmos. It is a quiet and humbling privilege to be a momentary witness to this immense and ancient spectacle. The act of looking at the night sky is an act of looking back through cosmic time. Let this be a final quiet thought to hold as you drift. The sky above you is not a place, but a time machine. The light of the moon is from a second ago. The light of the planets is from minutes or hours ago. The light of the stars is from centuries or millennia ago. And the light of the galaxies is from millions or billions of years in the past. Your eye in this moment is the quiet and peaceful destination for 1,000 different journeys of 1,000 different ages. The entire, vast and silent history of the universe is gently and peacefully converging, right here, right now, in your own quiet and restful awareness. The universe is not just a place we are in, it is a story we are. We are not separate observers looking at the cosmos from the outside. We are woven from its very fabric. The iron in our blood, the calcium in our bones, all of it was forged in the hearts of stars. The water in our bodies is as ancient as the solar system itself. The deep circadian rhythms that call us to sleep are tuned to the turning of our planet. We are a part of this great cosmic story, a brief and beautiful chapter in its endless unfolding. And the quiet, restful act of sleep is our own personal and profound way of participating in its deep, silent, and peaceful rhythm. The Whirlpool Galaxy is a perfect grand design spiral connected to a smaller companion by a bridge of stars. It is perhaps the most perfect and beautiful example of a spiral galaxy in our night sky. We see it face on, its two long, graceful, and well-defined spiral arms swirling out from its bright yellow core. These arms are filled with the bright blue light of young, hot stars and the pinkish glow of star-forming nebulae. It is a picture of a vibrant and active galaxy, and just off the end of one of its arms is a smaller companion galaxy. The gravity of this smaller companion is what is thought to be responsible for the larger galaxy's perfect, grand design spiral structure, the two of them forever connected by their quiet, invisible, gravitational influence. Intergalactic space is the vast, cold, and almost perfectly empty space between the great cities of stars. We have spent much time wandering through the bright and beautiful objects of the universe, but the vast majority of the universe is not these objects. It is the space between them. Intergalactic space is a place of profound and almost unimaginable emptiness. It is a near-perfect vacuum, colder than any natural place on Earth, and darker than our minds can truly conceive. But it is not a complete nothingness. It is filled with a thin, tenuous, and almost undetectable web of gas. And it is the medium through which the ancient light of the galaxies travels on its long, silent journey. It is the great, quiet, and peaceful ocean in which the glittering islands of the galaxies are set. Every point of light in the night sky is either a star in our galaxy or an entire other galaxy far away. This is a simple and beautiful way to organize your view of the night sky. If the point of light is sharp and twinkling, you are looking at a star, a single, sun-like object that is a relatively close neighbor inside our own Milky Way. But if you see a faint, fuzzy, and extended patch of light, no matter how small, you are looking at something else entirely. You are looking at an entire separate galaxy, a distant island universe containing its own billions upon billions of stars. The entire vast and complex story of the cosmos is written in these two simple kinds of light. The universe is a place of immense, quiet, and breathtaking structure. From the single perfect sphere of a star, to the flat, graceful disk of a galaxy, to the vast, interconnected web of the entire cosmos, the universe is not a place of chaos. It is a place of deep, profound, and beautiful order. Gravity, acting patiently over billions of years, has sculpted the matter of the universe into these magnificent and hierarchical structures. It is a quiet and constant reminder that the universe is governed by laws that are both simple and elegant, laws that can build cathedrals of breathtaking beauty out of the simplest of materials. Our galaxy is just one of an estimated 2 trillion galaxies in the observable universe. Let that number settle into your mind, 2 trillion. For every single person on Earth, there are over 250 entire galaxies out there in the observable universe. Each one of those galaxies contains, on average, hundreds of billions of its own individual stars. The sheer number of worlds, the sheer number of suns, the sheer amount of existence is so far beyond our ability to comprehend that it becomes a kind of deep and profound peace. It is the peace of letting go, of realizing that we are a tiny, fleeting part of a reality that is so much grander, so much older, and so much more wonderful than we can ever fully know. A black hole is a place where gravity is so strong, it has curved space-time into a one-way door. A black hole is not an object that you can touch or stand upon. It is a region of space-time itself, a place where a very massive star has collapsed under its own weight and has bent the fabric of reality into an extreme and inescapable shape. The edge of this region is called the event horizon. It is not a physical surface, but a threshold, a point of no return. Anything that crosses this threshold, a beam of light, a cloud of gas, a wandering star, can never come back out. It is a one-way door in the universe, a quiet and mysterious portal from the known into the unknowable. It is a place where the rules of our familiar world gently come to an end. Time flows more slowly near a black hole. An hour near its edge could be 1,000 years for the universe outside. This is one of the most gentle and wondrous aspects of these mysterious objects. The intense gravity of a black hole doesn't just curve space, it also deeply curves time. The closer you get to the event horizon, the slower the river of time flows for you compared to the rest of the universe. If you could hover in a spaceship just outside this boundary for what feels like a single hour and then return to Earth, you might find that thousands of years had passed for everyone else. A black hole is a natural time machine, a place where you can take a short, quiet rest, and in doing so travel deep into the far, distant future of the cosmos. A neutron star is the collapsed core of a giant star, so dense that all its atoms have been crushed together. When a star, much more massive than our Sun, explodes in a supernova, its outer layers are blasted away, but its core collapses with incredible violence. Gravity crushes the core so intensely that the very structure of atoms is destroyed. The protons and electrons are squeezed together to form a single, giant, city-sized ball made almost entirely of neutrons, packed together as tightly as in an atomic nucleus. A neutron star is one of the densest objects in the universe. It is a single colossal atom, a smooth, perfect sphere of pure nuclear matter, a quiet and incredibly heavy remnant of a once great star. A single spoonful of a neutron star would weigh more than all of humanity combined. It is a comparison that helps our minds to touch the almost unimaginable density of these objects. Imagine taking a small ordinary teaspoon and scooping up a tiny bit of the material from the surface of a neutron star. That single small spoonful would have a mass of billions of tons. It would weigh more than Mount Everest. It would weigh more than the entire combined weight of every single human being on our planet. It is a state of matter so extreme, so compressed, and so far beyond our everyday experience that it exists as a quiet and profound reminder of the sheer, crushing power of gravity. Some neutron stars spin hundreds of times a second, sweeping beams of light through space like a lighthouse. When the core of a giant star collapses to form a neutron star, it is like an ice skater pulling in their arms to spin faster. The neutron star retains the angular momentum of the original star, but in a much, much smaller package, so it spins at an incredible rate. These spinning neutron stars also have extremely powerful magnetic fields, which can channel jets of radiation out from their poles. As the star spins, these jets of light are swept through space, and if one of these beams happens to sweep across the Earth, we see a regular, repeating pulse of light. It is a silent, cosmic beacon, a star that is blinking with a precision that is almost perfect. These are called pulsars, the universe's most perfect and reliable clocks. The regularity of the pulses from a pulsar is truly astonishing. Some of them are more accurate and more reliable than our best atomic clocks here on Earth. They are the most stable rotators known in the entire universe. Astronomers can use the signals from these pulsars for a whole range of wonderful things. They can be used to test the laws of general relativity, to search for gravitational waves, and even as a potential navigation system for future spacecraft traveling through the galaxy. Each pulsar is a tiny, spinning and incredibly faithful celestial metronome, ticking away the seconds with a quiet and almost perfect cosmic precision. The four fundamental forces of nature are the quiet, invisible rules that orchestrate the entire cosmic dance. Everything that happens, from the slow turning of a galaxy to the gentle firing of a neuron in your brain, is governed by just four underlying principles: gravity, electromagnetism, and the two nuclear forces, the strong and the weak. Gravity is the great, silent sculptor, gathering matter into stars and planets with a gentle, long-range embrace. Electromagnetism is the force of light and life, binding atoms into molecules and allowing for the beautiful chemistry of our world. The strong nuclear force is the powerful, short-range glue that holds the hearts of atoms together, while the weak force governs the patient, slow decay that allows stars to shine. These are not loud, chaotic commands, but the deep, silent, and unchanging logic of the universe. They are the grammar of reality, the four simple rules that allow for the creation of every complex and beautiful thing that has ever been. Neutrinos are ghostly particles that pass through the entire Earth as if it were not there.
Every second of every day, hundreds of trillions of these tiny,
almost massless particles are streaming from the sun and passing through your body, through the chair you are resting on, and through the entire planet without ever touching a single atom. They are born from the nuclear reactions in the heart of our sun and from distant, exploding stars, and they travel through the universe at nearly the speed of light. They interact with other matter so rarely that a neutrino could pass through a light year of solid lead with only a 50% chance of being stopped. They are the universe's most gentle and elusive messengers, a constant, silent, and completely harmless rain of particles that connects us directly to the fiery heart of our own star and the most cataclysmic events in the distant cosmos, a quiet, invisible river that flows through everything. The concept of entropy is a gentle, inevitable slide towards a state of ultimate peace. We often think of entropy as a measure of disorder, but it can also be thought of in a more calming way. It is the universe's deep and fundamental tendency to move from states of high energy and improbable order to states of low energy and peaceful equilibrium. A hot cup of tea slowly cools to room temperature. A tightly wound spring will gently unwind. On a cosmic scale, the universe itself is following this path. The great energetic fires of the stars are slowly, patiently radiating their heat away into the cold of space. Entropy is the arrow of time, the reason the past is different from the future. It is a gentle cosmic exhalation, a slow, inevitable, and deeply peaceful process of everything everywhere, gradually and quietly settling down. The speed of light is the ultimate cosmic speed limit, a gentle guardian of cause and effect. In our universe, there is a fundamental rule. Nothing can travel faster than the speed of light in a vacuum. This is not just a frustrating limitation. It is the very thing that gives our universe its logical structure. It ensures that an effect can never happen before its cause. It creates a clear and beautiful distinction between the past, the present, and the future. The light speed limit means that the universe unfolds in a coherent and orderly fashion, where one moment can influence the next in a steady, predictable flow. It is the gentle, unbreakable law that protects the timeline of the cosmos, ensuring that the story of reality is one that can be read from beginning to end, without paradox or confusion. Hypervelocity stars are suns that have been ejected from our galaxy, destined to wander the intergalactic void. At the heart of our Milky Way lies a supermassive black hole, a place of immense gravitational power. Occasionally, a binary star system will wander too close to this giant. In the complex gravitational dance that follows, one star might be captured by the black hole, while the other is flung away with incredible force, like a stone from a slingshot. These are the hypervelocity stars. They travel at millions of miles per hour, fast enough to escape the gravitational pull of the entire galaxy. They are silent, lonely exiles, destined to spend eternity traveling through the vast, dark, and empty spaces between the galaxies. A single, fading point of light on a journey to nowhere in particular. The pillars of creation are vast, beautiful columns of interstellar gas where new stars are being born. In a famous photograph taken by the Hubble Space Telescope, we can see one of the most beautiful and serene structures in our galaxy. Located in the Eagle Nebula, these are immense, towering pillars of cool hydrogen gas and dust, light years in height. They look like great, ethereal underwater mountains or the fingers of a cosmic hand. Within these dense, dark clouds, gravity is slowly and patiently crushing the gas together, creating the small, hot knots that will eventually ignite as new stars. The pillars themselves are being slowly and gently eroded and sculpted by the intense radiation from the hot, young stars that have already been born nearby. It is a place of quiet, majestic, and ongoing creation, a vast and beautiful cosmic womb. The water in your body is likely older than the sun itself. It is a strange and beautiful thought. The atoms of hydrogen and oxygen that make up the water within you are ancient, forged in the Big Bang and in the hearts of long-dead stars. But even the water molecules themselves have a long history. It is thought that much of the water on Earth was delivered by comets and asteroids that formed in the cold, outer regions of the protoplanetary disk that would eventually become our solar system. The ice in these comets was formed from the interstellar medium, the great cloud of gas and dust from which the sun itself was born. This means that a significant portion of the water you are made of predates our own star. You are a vessel of ancient interstellar ice, melted and given a temporary conscious home. The Earth's axial tilt is the gentle reason for the seasons. Our planet does not spin perfectly upright as it orbits the sun. It is tilted on its axis by about 23.5 degrees. This simple, gentle tilt is the cause of all the beautiful and life-giving changes of our seasons. When our northern hemisphere is tilted towards the sun, we experience the warmth and long days of summer, while the southern hemisphere is tilted away, experiencing winter. 6 months later, the situation is reversed. If the Earth had no tilt, our climate would be static and unchanging. It is this quiet, constant, and graceful lean that gives our world its rhythm. its diversity, and its beautiful cyclical story of growth, of harvest, of rest.
and of renewal. Hoag's object is a rare and mysterious galaxy that looks like a perfect golden ring.
It is one of the strangest and most beautiful puzzles in the cosmos. It consists of a perfect, bright, and nearly circular ring of young, hot, blue stars surrounding a much older, perfectly spherical core of yellow stars. In between the core and the ring, there is a region that appears to be almost completely empty and dark. Astronomers are not sure how such a strange and beautiful object could have formed. It is a quiet and solitary object with no other galaxies nearby that could have caused its strange shape. It is like a single, perfect, and mysterious piece of cosmic jewelry, a golden ring with a star for a diamond, floating alone in the deep, silent, dark. Neutron-star collisions are the cosmic forges that create the universe's gold and platinum. The iron in your blood was made in a normal star, but the precious heavy elements like gold, silver, and platinum require an even more extreme and violent event. For a long time, their origin was a mystery. We now believe that most of these elements are created in the final, cataclysmic moments when two ultra-dense neutron stars locked in a decaying orbit finally spiral into each other and merge. In that brief, violent collision, a small amount of the neutron-rich material is flung out into space, and in this environment of extreme heat and pressure, these heavy, precious elements are forged. Every piece of gold jewelry on Earth is a rare and glittering relic of the ancient, silent, and unimaginably powerful collision of two dead stars. The Botas Void is a vast region of space so empty it is sometimes called the Great Nothing. In our map of the large-scale structure of the universe, there is a region of space that is profoundly and shockingly empty. The Botas Void is a roughly spherical region of space, about 330 million light-years in diameter, that contains only a tiny handful of galaxies. If our Milky Way were at the center of this void, we would not have known that other galaxies even existed until the 1960s. The night sky would be almost completely dark beyond the stars of our own galaxy. It is a place of immense and almost perfect silence and solitude. It is a quiet and humbling reminder that the universe is not only full of structure, but also of deep, profound, and almost unimaginable emptiness. Quantum entanglement is the quiet, mysterious connection between two distant particles. It is one of the strangest and most beautiful ideas in all of physics, a phenomenon Einstein called spooky action at a distance. It is possible to create two particles, like two photons of light that are intrinsically linked. Their properties are tied together in such a way that if you measure a property of one particle, you instantly know the corresponding property of the other, no matter how far apart they are. If one is spinning up, the other is spinning down. This connection is instantaneous, seemingly faster than the speed of light. It is a quiet, invisible, and unbreakable thread that can connect two points in the universe, a silent and profound reminder that our understanding of reality is still in its gentle,
wandering infancy. The Oort cloud is a vast,
theoretical sphere of icy comets surrounding our entire solar system. Far beyond the orbit of Pluto, far beyond the furthest spacecraft we have ever sent, lies the great, cold, and dark reservoir of our solar system's comets. The Oort cloud is a truly immense structure, a thick, spherical shell of trillions of icy bodies that may extend almost a quarter of the way to the next nearest star. We have never seen it directly, but we infer its existence from the long-period comets that occasionally fall in towards our Sun. It is the deep, frozen, and quiet attic of our solar system, a place where the pristine, leftover building blocks of our worlds have been silently and peacefully orbiting in the dark for over 4.5 billion years. Lagrange points are quiet, gravitational harbors in space where an object can remain stationary, In any system of two large orbiting bodies like the Sun and the Earth, or the Earth and the Moon, there are 5 special points in space where the gravitational forces of the two bodies perfectly balance out. These are the Lagrange points. An object placed at one of these points will remain in a stable position relative to the two larger bodies. They are like quiet, invisible gravitational eddies in the river of space-time. We use these points as convenient and stable parking spots for some of our most important space telescopes and observatories. They are the calm, still harbors in the midst of the constant, swirling gravitational dance of the solar system. The smell of space, according to astronauts, is a faint and strange metallic scent. The vacuum of space itself has no smell, but when astronauts return from a spacewalk and remove their helmets, they report a distinct and unusual odor clinging to their suits and equipment. It has been described as the smell of seared steak, of hot metal, of welding fumes. This scent is thought to be caused by a combination of things: the reaction of atomic oxygen on their suits, the outgassing of the station's own materials, and perhaps the faint, lingering aroma of dying stars and polycyclic aromatic hydrocarbons that drift in the interstellar medium. It is the quiet, strange, and unexpected perfume of the final frontier, a faint and ghostly scent of the great, silent void. Cosmic rays are high-energy particles that travel through the universe at nearly the speed of light. The space between the stars is not completely empty. It is filled with a constant, silent, and powerful rain of cosmic rays. These are not rays of light, but single, high-energy particles, protons, electrons, and atomic nuclei that have been accelerated to incredible speeds by some of the most violent events in the universe, like supernovae in the regions around black holes. They travel for millions of years across the galaxy, and when they finally strike the Earth's upper atmosphere, they create a shower of secondary particles that rain down upon us all the time. They are the silent, invisible, and incredibly energetic messengers from the universe's greatest and most powerful explosions. The tidal lock of the moon means it always shows us the same quiet and familiar face. For almost all of human history, we have looked up at the moon and seen the same familiar patterns, the same man in the moon. This is because the moon is tidally locked with the Earth. Over billions of years, the Earth's gravity has slowed down the moon's rotation until the time it takes to spin once on its axis is exactly the same as the time it takes to orbit the Earth once. The result is that one side of the moon, the near side, is forever facing towards us, while the far side is forever hidden from our direct view. It is a quiet and stable end state of a long, slow gravitational dance, a cosmic partnership that has resulted in a constant, familiar, and deeply reassuring gaze. Protoplanetary disks are the beautiful, spinning birthplaces of new worlds. When a new star is born, it is surrounded by a vast, flat, and slowly rotating disk of the leftover gas and dust from its birth cloud. This is a protoplanetary disk. It is within these great cosmic potter's wheels that new planets are formed. Over millions of years, the tiny dust grains begin to stick together, forming larger and larger clumps. These clumps grow into pebbles, the pebbles into boulders, and the boulders into great planet-sized bodies that sweep their orbits clean. Our own solar system was once such a disk. To look at a photograph of one of these distant, beautiful structures is to see a new solar system in the quiet and graceful process of its own birth. Variable stars are suns that gently and rhythmically brighten and dim over time. The night sky can seem like a static and unchanging place, but many stars are not as constant as they appear. Variable stars are stars whose brightness, as seen from Earth, changes over a regular period. Some of these are eclipsing binaries where one star passes in front of its companion, causing a temporary dimming. But many others are intrinsic variables, single stars that are physically pulsing, swelling, and shrinking like a great, slow cosmic heart. These Cepheid variables are incredibly important tools for astronomers, as the period of their pulsation is directly related to their true brightness, allowing us to accurately measure the vast distances to other galaxies. They are the standard, rhythmic candles of the cosmos. The sound of the universe can be heard by translating radio waves into audible frequencies. While space itself is silent, the objects within it are constantly emitting radiation across the entire electromagnetic spectrum, including radio waves. Radio telescopes are designed to capture these faint, cosmic signals. And while they are not sound waves, we can take these radio signals and translate them into a range that our human ears can hear. When we do this, we can listen to the strange, deep, and beautiful music of the cosmos. We can hear the steady, rhythmic beat of a pulsar, the gentle background hiss of the cosmic microwave background, and the strange, whistling symphony of Jupiter's powerful magnetic field. It is the quiet and haunting soundtrack of our vast and beautiful universe. And so our wandering through the sleepy wonders of the universe comes to its gentle close. We have drifted from the familiar blue sunsets of Mars to the silent, ghostly dance of colliding galaxies. We have listened for the faint, fading echo of the universe's first light, and we have felt the deep, quiet peace of the vast, empty spaces in between. The journey is ending now, and all that is left is the stillness that remains. We have touched the immense, slow and patient rhythms of cosmic time, and in doing so, perhaps we have felt our own small, hurried rhythms begin to soften and slow down. We have been reminded that we are made of stardust, and that our own quiet, resting bodies are a small, temporary and beautiful part of this vast and glittering whole. The same quiet laws of gravity that hold the planets in their graceful, silent orbits are holding you gently now. The same ancient starlight that has traveled for 1,000,000 years to reach us is filtering down through the quiet of your room. You are not separate from this great sleepy cosmos.
You are a part of it.
So now let yourself drift into that quiet cosmic dark. Let go of the journey.
Let go of the day.
There is nothing left to do but rest. Good night.